Good morning. So today we're going over how to graph these polynomials, and first going over how to find the x-intercepts. So if you read the instructions, notice we have to find the n behavior, the y-intercept, and the x-intercepts. Then use that information to graph the function and make sure to label all intercepts. So here, I'm going to do one example. F of x equals negative x minus 5 times x minus 4 times x plus 1. That's a factored form. And the standard form is negative x cubed plus 8x squared minus 11x minus 20. So let's first find the n behavior and behavior. So I look, okay, the highest exponent is 3, so it's an odd degree, and it's negative in front, that term. So the leading coefficient is -1. So the function, the two ends goes in opposite directions, and it goes from positive to negative, like something sloping down, positive to negative, like that. So I always like to draw out arrows right off the bat to show where my end behavior will be, like that. Okay, so there's my end behavior. The y-intercept is fairly straightforward. It's just that c value right here. And that's -20. Then the x-intercepts, I take the factored form and I set each factor to 0. So I say x minus 5 equals 0, x minus 4 equals 0, x plus 1 equals 0. So if I solve each of them, I have 3 intercepts. X equals 5, x equals 4, and x equals -1. All right, so I'm just going to graph out those points and then draw the graph. Draw the graph of the polynomial. Okay, so -20, this isn't quite to scale, but just write the correct numbers, on the right sign, right? -20 is obviously less than 0. So then I mark the other ones, 5, 4 for the x-intercepts, and -1. Now, as I mentioned in class, if you make an error, most of the time, it won't work out correctly. You have to start over here where the end behavior starts. You go through each of these points, and only these points. You can't add any and you can't subtract any. You have to do exactly these number of points, and it should end up down here. If you make an error, it's sometimes very obvious because, for example, if the y-intercept is the opposite sign, you'll end up on the wrong side of the graph when you get to 0. But in this case, that's not the case. You go down, go through -1, you can go through -20, right? The y-intercept's negative, that's correct. Go through 4, go through 5, and it ends up on the correct side, which is the negative side. So again, this graph matches the n behavior, the y-intercept, and the x-intercepts. I'm actually going to, instead of fixing my graph, I'm actually going to try to move these points over. All right, move over maybe rewrite this 4 here. But you get the idea. It goes through each of the intercepts once, and you can do a rough sketch of the polynomial. So you're going to do this same process with these 4 different polynomials. And I have to delete this. This is how I put together these problems. So for each of them, you have to find the n behavior, y-intercept, and x-intercepts. One last note, there's actually a fairly straightforward way to find all of this with just the factored form. Notice that you never use the terms in the middle. You just need the constant term at the end and the lead term. So for example, here we have x 3 x's, so I just say x times x times x is x cubed. The negative means it's negative. So I can find the end behavior just by counting the number of x's and seeing what sign is in front. Likewise, to find the constant, I don't need to do all the multiplying to get the stuff in the middle. I just need each constant, 1 times -4 times -5, that's 20. Then I multiply it by whatever is in front to get -20. Right? So that's something to keep in mind later on. I won't actually give the standard form, and you should be able to still find all the information. But for now, just do your best with what's here. Please contact me if you have any questions. Remember to attend tutoring if you need help. Always available through Google Classroom or through email. All right, have a good rest of your day. Just try your best, and I will talk to you next time.